Hello, welcome back for another fun and exciting lesson here in Algebra 2. Today we are going to focus on our lesson number 6 on page 21. Okay, today we're going to practice using the stow key on the calculator. It looks like this. And we can use this key to obviously store values into our variables. It is located right here on the calculator. Okay, so we're going to do a couple problems where we're going to store different values in for x and evaluate the problem. Okay, so let's get to it. So our first problem is this trinomial, and we want to evaluate it for when x is 5. So you're going to go over to your calculator, and you want to make sure that you're going to store x is 5. But it's a little weird because you can, so let's say you do 5, hit the stow key for x, and then hit enter. And then it gives back the 5. If you try typing the x in first and did x store 5, it's going to give you like an error message. And that just means you have to swap it around. Sometimes like you forget. So we just hit clear. And again, you type the number in first, store it for what variable you want, which in this case is x, and then hit enter. So now what's kind of cool about this is you can just type in what you see. So you would hit the x key, the squared. You see that x squared comes up, minus 2x. Make sure you don't use the negative key, plus 7. So you make sure you have the trinomial correct, hit enter, and you'll see that you guys got 22 for that. So if I go back, this one's just going to be equal to 22. Next, we also have a fraction, so we can practice our like alpha y equals and number 1, and that's going to create the fraction for us. So I'm going to show you that on the calculator. All right, so we're going to go back. We want to store x is -10. So now you would use the negative key, 10, stow it for x, hit enter, and it's telling you that you do have -10 in there now. Then we want to go to alpha y equals, and it's the number 1 that says numerator over denominator. That's telling you it's a fraction. And now you see the fraction. You type what you see. 2x plus 6 on top. Hit your down arrow to get the 3x minus 5. And then you hit enter. And for my calculator, I have it where it's given to me as a fraction, so it's 2/5. If you got a decimal, you can just hit math, enter, enter, and it will put it as a fraction. Because usually you want these as fractions. And now remember we have our absolute value, which you can get a couple different ways. I did show you guys that you can hit like the alpha y equals and then hit, I believe, like the right arrow. Let's double check it. And for this problem, we want to store x is 2. So I go 2, store x, hit enter, and it tells you it's in for 2. Now to get absolute value, I was showing you the other day, if you hit alpha y equals and you go over, hit the right arrow to function, you'll see your absolute value. Okay, that's just one way to get it. And we want 7x minus 20. Now you want to make sure you hit your right arrow to get outside of that absolute value. And then you want to do plus x squared. And then hit enter. And you should get 10. If you don't, double check with the neighbor. Maybe you typed something in wrong. Okay, and that is our store feature. Okay, so now we want to look at this example. Okay, and we want to try like using the calculator and by hand so you could see what the calculator is kind of telling you. So let's say we're going to store x is 5. So I'm going to go back. Just minimize that. I'm going to do 5 store. Oh, wrong thing. Hit clear. 5 store x. Hit enter. Okay, now I want the square root symbol, which is right above your x squared. You have to hit second x squared. And I want to type in 6 minus 2x. And then hit enter. It's going to tell you that it's a non-real answer. Okay? So let's see, like, why is that happening? Right? So let's go back to do it by hand. So now by hand, if you plug in the 5 for your x, you're going to get 6 minus 10, which is going to give you that negative number. So you get an error because of a negative. Okay. All right, so we're going to do some algebra and do some testing. All right, so we want to first find their product in their trinomial form, okay, which you guys have all been doing. I'll do this quick. I'm going to actually just jump to the answer. Okay. All right, I'll do the work. Just so you can see it. I'm going to do double distributive property. And you should get 3x squared plus 17x plus 10. And now they want you to evaluate the trinomial and the original. Okay? So we want to do both. So we want to take the original product. Well, let's first do the trinomial. And we want to evaluate for x is negative 2. Okay? So you could use your store feature, but let's just practice some of our math. Okay, so you're going to get a 4 here. We could just write a negative here. Negative 34 plus 10, so 12. If we're just showing all our work, I'll squeeze this in here. You should get a negative 12. And now they want you to take the original form, which was the 3x plus 2, and the x plus 5, and we want to plug in the negative 2. Just be careful. And what do you guys notice here, right? Negative 6 plus 2, that's going to be negative 4 times 3. You guys notice that you get the same answer. So that's proving to you that what you did is equivalent. Okay, so it's saying that this trinomial that I'm circling is equal to it written as a product. And then you also know that you did it correctly. So the last part says to you, all right, let's use the store feature. Okay, now let's evaluate the trinomial for negative 5. Okay, and let's see what happens. So we're going to take our trinomial, right? We're going to type that. I'm going to go to the calculator. We go over to the calculator. We want to store negative 5. Store it in for your x. Okay, and now we want to type in that trinomial, 3x squared plus your 17x plus 10, and let's see what we get. Whoa, we got a 0. What is going on? So why did we get a 0? Why did we get that? Reasoning why is our negative 5 is a 0. Okay, if you look back at the original up here, you see x plus 5. So we were talking about this, that x equals negative 5 would be considered a 0. Okay, let's try another one. Okay. Now they're going to show you, let's show you guys, how do we use our calculator to find the 0, right? So we're going to take this polynomial, this right here, and we're going to type it into y equals. So you want to go to y equals, and we're going to type that polynomial in. So let's go. All right, so go to your y equals, type this in, x, remember the caret key, raises it to any power, just hit your right arrow to come out of the exponent, plus 2x squared, right, minus 16x, and minus 32, okay? And we want to try to find some zeros, okay? So we're going to hit second graph. That gets us our table. Ooh, look at that. Now, depending on where yours is, you might have to scroll. Ooh, I see a couple. All right. So I see a 0 at, you're looking for a 0 in the y1 column. Okay. And you actually see a couple of them. I see -4. I see -2. And then if we keep going, I see 4. All right. So let's copy that down. So we had from -4 to 4. Right, so we can write a little table. So -4 gave a 0. I think -2, right? -3 was 7. And then you had -1 was -15. 0 should have been -32. One, 2 is -48. 3 is -35, and 4 is 0. So you have like quite a few that could be 0. So you would have like x equals -4, x equals -2. X equals 4. All 3 of these are zeros because they produce a 0 in the y column. Okay. All right, so let's try another little technique. We'll go to the next one. Okay, so we got a big one here. You got 2 sets of binomials that I want you guys to expand and then simplify, okay? So let's take your first 2, the x plus 5 and x plus 8. Right, so we're going to take x plus 5. Okay, you'll distribute or box method. So I'm going to do this kind of quickly. So you should get x squared plus 13x plus 40. Okay, then we're going to do the other pair. Okay. Now notice that there is a minus here, so that's going to come into play. I'm going to kind of keep this like right here. And now I'm going to go okay, now you have to be careful because there's this subtraction, but we need to group the trinomial together because you have to subtract the whole trinomial. Okay, so now we're going to combine some. We've got x squared plus 13x plus 40, but you want to distribute the negative to everything. Okay, and now you just want to combine like terms. So you notice that your squareds will cross out. You're going to get 12x plus 46. And this, because it's x to the first power, this is called, it's in linear form. All right, so what we want to do now, okay, we want to take the original polynomial and the new one that we just found, and we want to compare to see if we actually did it correctly. So let's show you what this will look like. Okay, so you guys will have like an X column. Then in Y1, we want to put the original polynomial. And then you'll know if you did it correctly. Okay, so there's the original polynomial. Okay. And then in Y2, we're going to put the other one. Okay, and then we'll just pick some values. We don't have to go crazy. Okay, and let's see what happens. So we're going to go to the calculator, go to your y equals, clear that out, type your expression. You can use your parentheses. Okay, and you got to hit minus x plus 3. Then x minus 2. Then you hit your down key, and we're going to type the 12x plus 46. Okay, now if I go to my table, so you hit second graph, you should see that the blue and the red are the same. Right? And you just have to verify this. You know, they want you to copy. I want you to copy down that for 0, it was both 46. And then it was 58, 70, and 82. And then you know that you simplified that properly, which is kind of cool. All right, making those connections. Okay? So you can start, if there's time left, what you can do is start working in your packet on page 23 and 24. It's a lot of calculator stuff, so it's not hard though, and there's some thinking questions in there. And then don't forget to work on your review sheet as well, and we'll go over all that on Monday.